Even seasoned researchers can face unexpected results. Today, I will tell you a real story about a life science experiment. It is an experiment that did not go well. The researchers did not expect the failing experiment. The result was very different from what they had expected. But after multiple rounds of troubleshooting experiments, they solved the problem. Do you want to know the reason why the original experiment did not work? Well, today, we will set the stage for understanding the problem. In the coming episodes, we will explore the reason why the experiment failed. But if you want me to give you a clue now, it was related to negative controls. If you are my good listener and you listened to the last episode, the key word will be the assumption 2 of negative controls. I hope the story will be very helpful for us to think that negative controls are important in life science experiments. Hi everyone, welcome to the Foundational Skills in Life Sciences podcast. I'm your host, Dr. Synaptologica. We discuss the skills that life science scholars learn, use, and improve throughout professional activities. Your benefit is expressed in my motto, learn the skills, enjoy academic life. Last episode, we are in a mini-series about how to read a scientific paper that led to the Nobel Prize. Our step 11 is devoted to understanding the milestone graph. This is the most important graph in our milestone article 1 that eventually led to the Nobel Prize in Physiology or Medicine 2023. This graph is in figure 3D, D as in dog, of our milestone article 1. It is the paper published in the journal Immunity in 2005. In the last episode, our substep was step 11-5, identify the negative controls of experiments. I will give you a brief summary of the last episode here because we need this information to understand the following few episodes. There are 5 points. 1. We defined a negative control. We started from a typical definition that you might find, and then we modified it. After the modification, we would say that a negative control is a sample where the expected outcome is thought to be absent instead of known to be absent. 2. We identified one negative control in our milestone graph. In this transfection experiment, the transfection reagent lipofectin was applied to the cells, but in the absence of any RNA. It is a form of mock treatment negative controls. A mock treatment mimics the manipulation or procedure in the positive control group or the test group, but without the active component or ingredient. 3. Then we discussed our 2 important assumptions about mock treatment negative controls. If either of the 2 assumptions is satisfied, the mock treatment negative control will work well. Here's a brief side note. When I talked about the 2 assumptions in the last episode, I forgot to add the term positive control. The positive control is now added properly in the following descriptions. Now back to the list. 4. Assumption 1 says that when the negative control shows almost a 0 measurement value, the measurements in the positive control group and in the test group can be used, most likely as they are. Assumption 1 is satisfied in our milestone graph because the mock treatment negative control showed almost a 0 measured value, so it was a good negative control. 5. Assumption 2 says that if a mock treatment negative control shows a large, non-zero measurement value, the negative control will work if the measurements of the positive controls and the test group are independent of the measurements of the negative controls. This assumption is important because in many experiments by any researchers, a mock treatment negative control often shows a large measurement value. Today's episode. In today's episode, we will start going deep into negative controls. Some of you might be thinking, isn't all this talk about negative controls a bit hypothetical? Are they really that important? To answer that, let me share with you a story. It is a real story that shows the practical power of negative controls in life science experiments. It is a story about an experiment that did not go well. It was not my experiment, but I have seen it unfold. The experimenters were at first confused and puzzled by the problematic results. Then they did troubleshooting experiments, and in the end, they solved the problem. Today, I will tell you the starting problem that the experimenters faced. We will go deeper in a few episodes. There we will talk about the further details of the story in sequence, as the experimenters did the troubleshooting experiments and solved the problem. We will see how they proceeded. Based on the story, we will discuss Assumption 2, which we left unexplored in the last episode. We will also discuss our modified definition of negative controls. By the end of these episodes, you will clearly see what we mean by Assumption 2 and why we modified the definition of negative controls. So our topic is deeply related to understanding any experiment, including our milestone graph. Let's now imagine that you are a member of the research team. As the story progresses, see if you can come up with ideas to solve the problem. A story about a problematic experiment. There was a team of well-experienced experimenters. They designed a new experiment. They were working on cultured cells, like the 2023 Nobel Laureates did in our milestone Article 1. In this experiment, the experimenters were trying to show that a treatment of the cultured cells with a certain chemical compound would increase the functions of those cells. For this purpose, their protocol went like this. I will give you 5 procedures. 1. The cultured cells were maintained in the culture medium for 1 week before the experiment. 2. During this culture period, the culture medium contained animal serum because cultured cells were better maintained when the serum was present. Serum is a common ingredient in culture medium. 3. On the day of the experiment, the experimenters replaced the old culture medium with a fresh medium and waited for 1 hour. During this stabilization period, no stimulation was applied to the cells, so the cell function would calm down and stabilize at a baseline level. This stabilization would make a good contrast with a subsequent increase in cell function by the chemical compounds. So the measurement of increasing function would become clear. 4. After the stabilization period was over, the experimenters applied the chemical compound to the culture medium and waited for 1 hour. 5. After this treatment period was over, they measured the functions of the cells. So in summary of the experimental design, there were 3 periods: the culture period, then the stabilization period, and then the treatment period, and then the measurement. In a pilot experiment, there were 2 groups of cells. The cells in the positive control group were treated with an active form of a chemical compound. The cells in a mock treatment negative control group were treated with an inactive form of the same chemical compound. The other research groups had already reported that the active form would increase the cell function in their hands and that the inactive form would not. So these compounds would serve as a positive control and a negative control properly. The experimenters' plan was twofold. Initially, they would confirm the effect of the positive control in this pilot experiment by comparing the positive control with the negative control. And then the experimenters would examine the effects of other chemical compounds as a test group, using the same positive and negative controls as a reference. This is the end of the explanation of the experimental design. What the experimenters found. Then, what did the experimenters find in the pilot experiment? What the experimenters found with the positive and negative controls was difficult to understand. They had expected that the active chemical compound in the positive control would increase the function of the cells, but the experiment showed that the cells in both the positive and negative controls behaved the same way. There was no difference between positive and negative controls. So the conclusion was that the active chemical compound had no effect. It did not increase the cell function. The experimenters were disappointed because it was very different from what was known in the field. The other research group had reported before that the active form would increase the cell function in their systems. Question. Now, can I ask you a question? What happened in the experiment? Is it true that the active chemical compound had no effect? What are your thoughts? Here is a brief comment. If you and I are on this research team together, we will probably be scratching our heads trying to figure out a solution. But even if we are outsiders looking in, for example, we are having a small group discussion session in a classroom, this story can spark some interesting discussion. I love brainstorming sessions. So whether we are in the thick of it or offering fresh perspectives, you and I will exchange ideas freely. This is it for today. In the next episode, we will keep talking about this experiment. We will see a major flaw in the experimental design that led to the problem. Now, your action. Until we meet next time, try thinking about what could have gone wrong in the experiment of today's story. How would you solve the problem? What are your thoughts? When you get an idea, please send me an email about it. We can think about it together. My email address is ideas@synaptologica.com. Thank you for joining me in today's episode of Foundational Skills in Life Sciences. I am Dr. Synaptologica. I'll see you soon. Bye for now.